Hello students, welcome to the BYJU'S exam prep. In this session today, me and Dheeraj sir will be solving some frequently asked topics of previous year questions of XZ. That means we have selected those questions of XZ, engineering science, that have been repeatedly asked in last 15 years. So those few questions, to be very precise, 21 questions we will be solving today. Okay, now this session is equally important for civil and mechanical because it has been observed many times that a question of XZ has been asked in civil and mechanical gate paper after 3 or 4 years with a different value. So it is equally important for civil and mechanical students both. Even if you are not given the second paper as XZ, still it is important for your own paper. XZ is also having one of the subjects as solid mechanics, which includes the solid mechanics of XZ includes SOM plus vibration plus engineering mechanics. Okay, so vibration and engineering mechanics sessions we will also be taking, Dheeraj sir will be taking soon. So directly let us go to Hisar, to Dheeraj sir, to the master blaster, the champion, the commando, the PhD, the doctor, everything of SOM. Okay sir.
सर मुझे लगा था अभी आप और भी काफी सारे प्रोफेशंस बोल दोगे, पेंटर ये और वो. So guys, so as many students were requesting, sir, we are not getting the PYQs of XC, and if we are getting, solutions are not correct in majority of the books. So that's why by taking that into account, we thought to take the important PYQs, and if you guys would be feeling this useful for you, we will be coming up with more sessions also. Because as you know, 35 marks is going to be there for solid mechanics part if you are appearing for XC. Okay, so guys, today we are having 21 questions as sir already have told, and we will be covering questions in such a way that they are covering all the concepts like simple stresses, thermal stresses, bending, torsion, SFD, BMD, deflection, strain energy, everything is covered. Okay, so in that way, first sir will be starting with some questions, then I will be coming, and one by one we will be rotating like that. Okay, so sir, shall we start?
Yes, sir. Okay, guys, this is our Telegram group, mechanical by Dheeraj sir and civil by Abhinav sir. This is the rank up series, guys. Write down, it is going on the Telegram on our YouTube channel for civil and mechanical both. You can enjoy these rank up course where we are discussing 500 questions in the total series. Let us go without time wasting. The PYQ of XZ. All these are PYQ of XZ branch. Okay, let me again tell you guys, the solid mechanics, which is of 35 marks in XZ, includes strength of materials, engineering mechanics, and vibration. Okay, even if you are thinking, sir, I have not attempted the second paper, I have not filled the gate by the second paper, guys, still it is important for you because it's the same questions many times with different data has been asked in civil and mechanical. Hi, Krupa, how are you? Can you check your complete total SOM? Yes, of course. This is the only syllabus, na? You one subject you can take SOM of 35 marks, FM 35 marks, and maths aptitude. That is the total syllabus you are saying. Okay. Now, guys, what is the sum of principal stress? Acha, ek aur cheez before I start this session, that usually what students tell me, na, sir, XZ PYQ I have seen. It is a bit difficult than the PYQ of civil or mechanical. To be very frank with you, let me say yes, it's almost correct. The difference is not much, but yes, there is a slight difficulty in the XZ. But तुमको वो ज़्यादा difficult इसलिए लगता है क्योंकि तुमने PYQ of SOM you have seen many times. So you are familiar with PYQ of your branch of SOM or mechanical. In classes you have discussed, in YouTube you have discussed. So जब भी कोई चीज फ्रेंडली लगती है ना, so आपको इजी लगेगा. एक अगर कोहली अपने होम ग्राउंड में मैच खेल रहा है तो उसको थोड़ा इजी लगेगा. सडनली सपोज इन स्पेन अ न्यू स्टेडियम हैज बीन डन, कंपैरेटिवली उसको उतना वहां पे इजी नहीं लगेगा. सेम थिंग हैपेंस, यू हैव गॉन थ्रू विद सो मेनी टाइम्स ऑफ पीवाईक्यू ऑफ योर ओन ब्रांच. सो XZ हल्का सा डिफिकल्ट है, लेकिन आपको उससे ज्यादा डिफिकल्ट लगता है बिकॉज यू आर सीइंग इट फर्स्ट टाइम. ओके, नाउ वन लॉन्ग मेथड फॉर दिस इज, you find it sigma 1 sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 whole square plus tau xy square, and you find out sigma 2. Sigma 2 is sigma x plus sigma y by 2 minus sigma x minus sigma y by 2 whole square plus tau x y square. And then what is asked? The sum of principal stress. You can find sigma 1 plus sigma 2. It will be coming as 100. One long method is this. But now you have seen the ad of Mentos. Now the Mentos Zindagi. Okay. Now what is done there in Mentos Zindagi? That the sum of two mutually perpendicular planes, the sum of normal stress is constant. So sigma x and sigma y are at 90 degree and principal stress are also 90 degree. So sum of principal stresses or sum of normal stresses on any perpendicular plane. Okay, sigma x dash plus sigma y dash, it is constant. Sum of normal stresses on two mutually perpendicular. This is also mutually perpendicular, this is also mutually perpendicular, is constant. So sigma x plus sigma y is 40 plus 60. So this is 100 megapascal. Okay, so this with lot of calculations that you are doing here, you can avoid this. Everybody give me yes or no. Okay, yes, after me, Dheeraj sir will be coming. After me, I'll be doing 6 questions, then Dheeraj sir will be coming, then sir will be doing some questions, then I'll be coming and I'll be doing some questions, then this kind of switching will be done. This is question number 1. And I guess you all can do it easily. You all can do it easily. Now, let us go to question number 2. This is the question, guys. Let me make the here like this. This is the supports here. This is the supports here. And one is metal 1, one is metal 2. Okay. This is the supports here. Okay. This is metal 1 and one is metal 2. Let this be metal 1. Let this be metal 1 and below this is metal 2. Now heating is done. Heating is done. This is metal 2. Okay. Now heating is done. Then force required to be applied to the rigid end to maintain the same length. Now let me make this, modify this question beautifully. Let me modify this question beautifully. Copy, paste. Let me modify this question beautifully. Okay. So this is question 2 actually. In this case, this will be question 2. Guys, here the answer will be none of these. Answer will be none of these, as the answer will be here 0. Answer will be 0. If it is written as rigid. Rigid end. So you need not to apply any force. Nah? You need not to apply any force if these support are considered to be rigid. If these supports are considered to be rigid, then even you are not applying any force, itself reaction will be provided. Nah? Itself it reaction will be provided. Nah? So it will be 0. Na Ghoda Sahab. Okay, father's horse. Yes, it will be 0. It will be 0. Because rigid support itself will be providing reactions. But yes, now let me take it question 2 dash. Question 2 dash. And let me write it here, composite system. Now these are not fixed supports. System, then the resultant photo will write to the rigid, to the plate, to the end plate. Now these are not rigid. So now it is composite system. Now this is composite system. Rigid means, guys, what is the difference between composite and rigid? What is the difference between composite and rigid? Rigid support, if it is mentioned at the two ends, then delta is equal to 0. So here you don't have to apply any force. Itself it will be 0. Itself it will be 0. No, without any force itself there is the same length. Now if it is composite, it means delta is equal to same. So if they were free, the coefficient of thermal expansion is alpha 1, alpha 2. Let alpha 1 be more. Let alpha 1 is greater than alpha 2. If they were free, then here it will be more elongation. Okay. And here it will be less elongation. If they were free, but it is composite. It is composite. So both have to settle to a certain value. And here in larger alpha, in case of temperature increase, not decrease, compression, and here it will be tension. But in this case, what will be happening? In this case, length will not be L. Okay, length will be same. Both are elongated by this amount up to white, but it will be some L dash. It is saying now force required so that delta is 0. That means length is same to maintain the same length. That means delta is 0. That means like fixed case. So fixed here, in fixed case itself the support will be providing reaction, but here you have to yourself provide, because if you are not provided, it is composite, it will be elongated. So you have to make it like fixed. So same length. So you have to make the force applied. You have to apply the force here. Otherwise, it will be elongated. So you have to make it like fixed beam. So in fixed beam, the stress here is E1 alpha 1T. Okay, stress is E1 alpha 1T. So force will be P1 force will be stress, that is E1 alpha 1 into delta T into area 1. This much force has to be done, because if we want to make it delta 0, for delta 0, this much stress is coming. For delta 0, this much stress is coming. Delta 0, then only the length will be L. So this much force will be there. And P2 will be, we have to make it delta 0. For delta 0, this much stress is coming. So force will be this much. So net force is equal to, you have to apply from either ends, compressive for temperature increase case, this will be A answer. Have you got it? Give me yes or no. Have you got it? Give me yes or no. Everybody on the comment section. Everybody on the comment section. Have you understood? Yes. Question 2 and 2 dash, both you have understood. Now question 3. The state of a stress at a point is given below. Both the normal and shear stress on a plane inclined at an angle of 45 degrees, 0. So from here, if I rotate this by 45 degree, okay, this white one and green one, this green one and this white one, this green plane is at an angle of 45 degree. And here the shear stress is 0. So in that case, what is tau xy in this white plane? So shear stress on this plane is 0. In green plane is 0. It is given by minus sigma x minus sigma y by 2 sine 2 theta plus tau xy cos 2 theta. So if this is 0, then it is minus of sigma x sigma y. How much is 200 and 200? So 200 minus 200, both are tensile. So 0 plus tau xy cos 90. Okay, cos 2 theta. So from here, for any value of tau xy, it will be 0 coming now. Please check, are we doing some mistake? Sigma x is 200 and it is also 200 by 2 into sine 2 theta. So this will be 0 plus tau xy cos 90. Please, I guess I'm writing the wrong formula. Let me check. This will be sigma x minus sigma y. Now formula is also correct. Sigma x minus sigma y by 2 sine 2 theta plus tau xy cos 2 theta. Please check, guys, formula. I am applying correct or not? Okay. Sine tau cos 2 theta and tau xy sine 3 theta. Please do check. Tau xy cos 2 theta is 0. Okay. Let it be from here. Tau xy cos 2 theta is equal to 0. Okay. Now after this, one more condition is given, that normal stress is also 0. So normal stress is, let me write it here. Sigma x dash on this green plane. Let me write with the better color. Sigma x dash on this green plane is sigma x plus sigma y by 2. Sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta cos 90 will be 0 plus tau xy sine 2 theta. So here sigma x dash value is given as 0. Both the conditions has to be checked now. So this is tau xy and sine 90. Sine 90 is 1. Okay. So from here, tau xy cos 2 theta is 0, tau xy sin 2 theta is 0. Okay. So in this case, guys, tau xy sin 1 is 0. So that means tau xy is 0. Both the condition is satisfied for tau xy is equal to 0. The shear stress in xy plane, the shear stress in xy plane, let me check. Guys, it is coming 0. Please, are we doing some mistake? अच्छा ये छूट गया ना, ये छूट गया यार, दिमाग ही नहीं चल रहा. Sigma x plus sigma y by 2. So 200 for 200. So 200 plus tau xy sin 2 theta is 1. So magnitude wise tau xy, are you getting 200? Please tell me. Tau xy is getting 200. Tau xy is 200 and this anyhow will be 0 yaar. Because cos 90 na. This anyhow will be 0. This anyhow will be 0. For any tau xy, this value will be 0 because cos 90 is 0. So from here, tau xy is 200. Give me yes or no, everyone on the comment section. Hi, APKL. Everyone, please let me know. Everyone, please. Understood? Okay, now let us go to question number 4. A simply supported beam of length L and flexural rigidity EI is uniformly distributed load like this. Uniformly distributed load is acting. Okay, let this load be W Newton per meter. Let this be A, let this be B. So here the deflection at the mid span. Very easy, guys. This is a standard result. Otherwise, you can derive it from strain energy. Okay, you can derive it from strain energy. You can derive it from area moment theorem. You can derive it from conjugate beam method. You can derive it from double integration also. So I guess all of you are remembering this. All of you are remembering this. Yes or no? Yes or no? Yes or no? 5. Yes. And for fixed beam, if it is fixed beam, delta of fixed beam is how much? Is how many times of delta of simply supported beam in case of UDL? Can anybody tell me this alpha value? How much times of fixed beam will be lesser? Nah, so alpha will be less than 1. Alpha will be less than 1. Okay, it is 1/5 of that. Now question number 5. Question number 5. In fact, it is 6 now because second question I have done it 2 times. Okay. So let me delete this. This is nothing. I cannot erase. I can erase in smartboard only the thing that is written from my pen. This printed I cannot erase. So I can put a black color over it. So it is erased now. So it is erased now. Now, guys, you have to find out the strain energy due to bending only. Due to bending only. Now, if I take this green member, then green member is like this. This green member is like this. So here the P force is acting. Okay, length is B. So from here also the P force is coming for balancing it. So from here also the P force is coming for balancing it, and this P into B. So here P into B will be acting in opposite direction for moment equilibrium also. About this point, this P into B is anti-clockwise. So here it is clockwise, P into B. But now the torsional strain energy is only due to bending, due to not any shear force or axial force, nothing. So in this green part, there is some strain energy U1. Okay. Now let us come to this yellow part. Now let us come to this yellow part of A length. So yellow part is of A length. Yellow part is of A length. Now internal force are always equal in magnitude and opposite direction. So here it will be P here. If here it is clockwise, here it is anti-clockwise, PB, and of course for balancing, here it will be P, and here it is PB for balancing. And even you can directly see this also. You can directly see these reactions from here also. If that is P, For summation fx, this will be p. This p is applying clockwise movement, and this will be applying here. Reaction can be directly seen here also. Now one is u1 and one is u2, and we have to find the total strain energy. Total. So what is u2? Mx square dx upon 2ei. Mx square u is, let me write the formula, due to bending. Bending moment at any section square dx upon 2ei. Okay. So for this yellow part, this is coming as mx is pb whole square into dx upon 2ei, and this integration is from 0 to a. This integration for this whole part from 0 to a. Please check 0 to a. So this will be p upon 2ei pb square upon 2ei into dx integration will be x and it will be a. Okay, so pb square by 2ei into a. Okay. Now for this green part, it will be mx square. M is pb whole square dx upon 2ei integration from 0 to b. So p square b square 2ei dx integration will be x, limit will be from 0 to b. So plus p square b cube upon p 2ei. Please check, are you getting the same value? So we take p square, this also should be p square, na? P square b square upon 2ei if you take common. P square b square upon 2ei if you take common, it will wait भाई यार दिमाग बिल्कुल नहीं चल रहा. Wait. So here at any x distance, here the bending moment is constant, na? Here at any x distance, here it is constant, so you written constant. Here at any x distance, the bending moment is px into square upon dx upon 2ei. So now from here, p square will be common, 2ei common, x square will be x cube by 3. So x cube by 3, so this will be 6. X cube by 3, so this will be 6. X cube integration will be from 0 to b. So this will be p square 6ei into b cube. Now from here, p square b square common. In both of them, if I take p square b square upon 2ei common. Okay, p square b square 2ei common. So here it will be how much left? P square b by 3. In green one, it is b by 3. And here it is how much remaining? A. Here it is how much remaining? A. So answer will be A option. Give me yes or no. Give me yes or no, everyone. Give me yes or no. Give me yes or no. Give me yes or no. Okay. Everybody understood? Now, question, this is last question, then Dheeraj sir will be coming. After this, Dheeraj sir will be coming. Okay. Now, everyone please see here. Let this be RP. Let this be RQ. Let this be RP and let this be RQ. Now, summation Fy0. Summation Fy0. So upward force is RP plus RQ and downward force is 2 into 2, 4. Downward force is 2 into 4, 2 into 2, 4. Correct? Now take summation of movement about any point. Let's take summation of movement about R is equal to 0. So it is itself showing here. This wala portion here same amount and this wala portion here same amount because both are 1. This wala portion here same amount and this wala portion here same amount because both are 1. Because both are 1. So this will be 0 anyhow. Clearly without calculation it is showing here. Without, let me do it here. RP, this is movement, not bending moment. This is movement, not bending moment. Okay, bending moment, I cannot say it is 0 at any point. It may or may not be 0, but movement for equilibrium beam is always 0. So RP into 2 clockwise and this total is acting 2 into 2, 4, and 4 is acting on the R only, center of mass. Okay, so RP is equal to 0. This is equal to 0, and total is 4. So total is 4 here. Okay, so if you draw the bending moment diagram, so here this is 0. So any part C from left hand side, there is no bending moment here. Bending moment only coming from here. Okay, bending moment is only coming from here. Okay, now if I draw, or if I find out the bending moment here at XX section from right hand side, so bending moment at XX section from right hand side, downward load from negative, total is 1 into X. 2 is acting at X distance. Let this be X distance. So 2 into X into center of mass is X by 2. So it is minus 2X square by 2. So it is minus X square. So maximum, it is minus X square. So maximum value will be coming here at X is equal to 1. That is 1. Similarly, from here also, if you go, the maximum will come here only. If you take here any section XX, let me take X from here. So again, it will be 2 into X by 2. And maximum value here only. So that value is 1. Understood? Everyone guys? Everyone guys? Please give me yes or no. Okay. So, धीरज सर.
जी सर.
सर आज थोड़ा मैं स्लो था क्योंकि मेरा दिमाग आज इतना, इसलिए मैं जल्दी थोड़ा टाइम लगा दिया क्वेश्चन सॉल्व करने में.
Sir, I feel you are going very busy these days.
Yes sir, construction is going on.
Okay sir.
ठीक है सर, आप फोड़ दो 7th क्वेश्चन से, फिर मैं आता हूँ जब भी मेरा नंबर होगा.
Fine sir, fine. Okay guys, so next question is this one. Question number 7 now we are having. So we are having all the types of questions. Some are easy, some are difficult. All types of questions are there. So this is a question where we are having a stepped circular shaft fixed at one end is subjected to 2 axial forces. Okay, these are 2 axial forces. And when we are saying the maximum tensile stress, they are asking. And let me see the second force also. This is question number 7. Okay, so I feel this is 50. Sorry, 200 kilonewton. This is 200 kilonewton. This is 300 kilonewton. So you need to find out the maximum tensile stress. I feel you know that if we say this member is A, this member is B, this member is C, then you can write the stress in AB member will be equals to 300 divided by pi by 4, 50 ka square. And when you will be writing sigma BC, you will be getting 300 plus 200, method of section. Everybody remember, na? To the right hand side, 200 plus 300, 500. So it is 500 divided by pi by 4 into 100 ka square. And it is kilonewton, so you can also put 10 power 3. So guys, this is from simple stress and strain. Then we have question from pure bending, from pure torsion, from SFD, BMD, deflection, thin pressure vessels, everywhere. So please tell me what would be the answer for this. 120, 210, 153 or 390. What will be the answer for this one? Tell me guys. The answer for this question. Yes, Papa ka ghoda. Tell me. Anupam, Mani. What would be the answer? Please tell me, guys. Yes. So guys, you need to tell the maximum tensile stress. What will be maximum tensile stress? Shall I give you the answer? when you will be finding out this sigma AB, this value will be coming out to be 63.66 MPa. And when we are talking about the second value, my dear, then the second value will be coming out to be around 152.48 MPa. So you can see which one is bigger, obviously 152.48. So the answer for this is going to be C, that is 153 MPa. Is it clear for everyone? Please tell me AB, PKI, money, Papa ka ghoda. Moving further to the next question. Arey bhai, nobody is responding. Next two questions are very, very important, guys. And this question is 2 times repeated in XC paper. If you see this question, they have mentioned the 10 mm thick steel rectangular plate of size 100 mm cross 200 mm. This is X, this is Y. And they have mentioned that subjected to biaxial state of stress. And that, yes, very good, very good, very good, very good. Okay. Now I am able to see your comments. Maybe due to some technical issue, I was not able to see the comments. Now it's fine. Okay. So now, my dear, you need to solve this question. Okay. Shrishti, AB ka 3.81. AB ka 3 point. Okay, you are saying about the previous question. It is not 3.81. It is going to be 63.66 and it is going to be around 152. So the answer is going to be C. Srishti, I feel some calculation mistake you are doing. Okay. So moving to this question. This is wonderful question. These two questions are wonderful one. And if you see the GATE 22-23 paper of mechanical, they have repeated these questions as it is. Okay. Just as it is means concept is same. They have changed the magnitudes only. So my dear, a 10 mm thick rectangular plate is this, and they are saying sigma XX is 150 MPa, sigma YY is 200 MPa. They have given you the Young's modulus as 200 GPa and Poisson ratio as 0.3. Okay. So these data are given to you, and my dear, they have also mentioned the dimensions and the stresses, everything. And what they are asking, they are saying the change in the thickness of the plate. So you know that thickness is in the Z direction. So I feel everybody is aware that epsilon ZZ is going to be the change of thickness by thickness, which is nothing but plus sigma ZZ by E minus mu times sigma XX by E minus mu times sigma YY by E. If you see, it is 2D state of stress given, so this will become 0. So my dear, you need to find out delta T. Delta T is nothing but T times minus mu times of sigma XX by E minus mu times of sigma YY by E. So in the GATE 2022 and 2023 exam, they asked it by taking the case of thin cylinders. Okay. So just try to solve this question. No issues, Srishti. You can try this one. This one is a wonderful question, and this was repeated in mechanical paper. So from XC, questions are continuously repeating in mechanical and civil, both the branches. Okay. So like this type of question repeated in mechanical, deflection type of questions are repeated in civil. So guys, we are covering both the things. Okay. And it can also come in civil. It is not like I am telling you the previous history. Okay. So try to solve this question. I want answer from all of you. Poisson ratio is 0.3. You just need to put the value and get the answer. You need to find out the change of thickness. Okay. The options available are 2.39 microns, 5.25, 7.12 and 9.16. So what you need to find out, delta T, thickness is 10 mm. Okay. And you know that it is minus of mu is 0.3. E is 200 GPa. This is common once again. Okay. So you can write here sigma YY and sigma ZZ. What is sigma YY and sigma XX and sigma YY? Sigma XX and sigma YY are 150 and 200. So it is 150 plus 200. So that will give you, my dear, the answer for delta T. So Papa ka Ghoda is saying A, 2.39. Please check it. Please check it. It is 10 into 0.3 divided by 200. into 10 to the power 3. This is 350. Please check it again and then tell me the answer. Yes, you are very close, Papa Kagoda. Try it. The solution is in front of you. You just need to put the value and get the answer. So guys, today we are covering only solid mechanics in the strength of material. And in the upcoming sessions, we will also take care of fluid mechanics, thermal, and the other parts of solid mechanics like engineering mechanics and vibrations part. Okay. So tell me the right answer. This is 10 mm. Okay. This is Newton per mm square. This is also Newton per mm square. So answer will be coming in mm. So you need to see that they are asking in microns. Tell me. Yes, now you are correct, Papa Ka Ghoda. B is the right answer. So answer for this is 5.25 microns. And I am telling you guys, this type of questions are now coming in GATE examination. Everybody got it? Srishti, Anupam, Krupa, please tell me that. So this is the answer for this question. Now, my dear, in the next question, what they are asking for the same data, they are saying the change in surface area of the plate. You know that you are going to apply two-dimensional tensile stresses. Here also tension, here also tension. So, my dear, because of that, we can assume that there will be extension in X and Y direction. So, they are asking the change of area. So, my dear, by using epsilon xx, which is nothing but sigma xx by E minus mu times sigma yy by E minus mu times sigma zz by E. You know sigma zz is 0. This will give you delta x because delta x by x this is. Similarly, you can use epsilon yy, which will give you sigma yy by E minus mu times sigma xx by E minus mu times sigma zz by E. So this will be giving you delta y. So when you will be getting delta y and delta x, you know what is the change of area. Very good, Srishti. The change of area will be, first of all, the new area, x plus delta x into y plus delta y. This is the new area. What was the previous area? X into y. So when you would be equating it, you will be getting the change of area. Okay, you will be getting the change of area. So this is how you can do this question, guys. Try to solve it. The data I am sharing with you, this is the data. Sigma xx is 150, sigma yy is 200, Young's modulus is 200, Poisson ratio is 0.3. So if you are going to find out this, I am writing this. It is 200, it is 150. Am I writing it correctly? Sorry, opposite. This is 150, this is 200. And Young's modulus is 200 GPa. Poisson ratio is 0.3. Okay, so you need to find out now. Solve it, guys. This is question number 9. Now we are going to have questions from torsion after this. Yes. So we are having a complete mix-up. Questions from Mohrs circles are also there. Question from SFD, BMD, deflection, simple stresses, thin cylinder, thermal stresses, torsion, strain energy, everything is included in this session. This is an overall package for strength of material practice. Tell me, guys, you need to find out this change in surface area. And guys, you know, mathematics is also going on Sunday. Tomorrow also 10 PM we are having a session. Tomorrow we will be having matrices, linear algebra. As last week I have taken the practice session where many students said that, sir, we forget the concepts. So taking that in mind, I am going to divide this matrix chapter into 2 parts where we will be discussing theory plus question like I have done for probability. So we will be having one session tomorrow 10 PM. One session would be in the next week. So in these 2 sessions, your entire matrix or linear algebra will be revised completely 100%. Okay. I will be sharing the notes also to you, PDF also to you. As you know, I'm sharing the handwritten notes of all the classes as well, and also the practice questions separately to you guys. Tell me, what would be the answer, bhai? इतना टाइम क्यों लग रहा है भाई कैलकुलेशंस में? From here you can get the value of delta x. From here you can get the value of delta y, because it is mentioned to us that what is x? X is 100, y is 200. So x is 100, y is 200. Yes. So Papa ka Ghoda have given the answer to be 24.50 mm square, which is correct. The answer is correct. You would be getting near by this. Very good. So answer is correct. Wonderful. So guys, the answer for this is going to be 24.5 mm square. What we have done? We found out the delta x from here. We found out the delta y from here. Then we already know x plus delta x, y plus delta y. This is the new area. This is the previous area. The change of area will be this. So guys, you will be getting 24.5 mm square. Very good. Moving further, guys, now we are coming to torsion topic. Okay, so if you see this question, a solid circular shaft of 50 mm diameter fixed at one end is subjected to torque as shown in the figure. The shearing modulus of the material is 80 GPa. So you can also see that, like, this is first, this is second, this is third. I am dividing shaft into three parts. They are saying the maximum shear stress due to torsion is, you know that the diameter is same throughout. It is a prismatic shaft. So for such case, obviously, whenever we are writing the tau value, it is T by ZP. So here ZP is same for the complete shaft. So obviously where torque is more, there stress will be more. So, you know, if you will be taking section at 1, right hand side, there is no torque. If you take section at 2, right hand side, there is 250 Newton. If you take section at 3, right hand side, 500 plus 250. So obviously you will be having the maximum stress in PQ portion. So here we will be having 750 Newton meter is the torque. Then ZP, you know, is pi by 16 dq. Okay. So they have given the length because next part is related to the angle of twist. So you know that this is T by ZP, and you know 50 mm is the diameter given. So you can find out the value of maximum shear stress. So this will give you the PQ maximum. So guys, you need to answer it. These are the options in front of you. Solve it and get the answer. Then second part of this is related to the angle of twist. Solve it and get the answer. Solve it and get the answer. Tell me. So after me, once again, Abhinav sir will be coming for 3-4 questions. Then I will also come for 3-4 questions. Total 21 questions are there. Okay. This is 10th and 11th going on. So guys, you know, every Saturday aptitude and every Sunday mathematics is going on. So don't miss those sessions, because maths and aptitude are very, very scoring subjects. So try to attend tomorrow also 10 p.m. and 2 sessions of linear algebra will make you master in that. And those PDF will be very good for revision of yours. Tell me guys, what you are getting as the answer. As it is Newton meter and it will be in mm cube. So take care of units as well. These are the options. Yes, Srishti, Anupam, Papa ka Ghoda. What you guys are doing, yaar? Are you saying A? Okay, what about others? What about others? This is the question, na? Yes. So you would be having 750 into 1000. Now it is Newton mm divided by multiplied 16 pi into 50 ka square. It is mm cube. Once again check it. Once again check it. So can you feel the calculation error are coming more in the XC questions from you guys? If you notice from the very first question. So that is what we were saying, that slightly typical questions are coming. Okay, slightly typical. Tell me, this is very simple. 16 into 750 into 1000 divide by pi into 50 ka square. If I will do in front of you now, I can do it in a minute very easily. I don't know why you are taking so much time. If you will do it 16 into 750 and into 1000 divided by pi divided by 50 ka square. Yes, are you getting 1527.88? 1527.88. So only Papa ka Ghoda have answered, none other have answered. Okay. So yes, you are going to get around 1527.88. Are you getting this? Yes. Again, some mistakes, Srishti. Fine. So guys, based on that, if you see, this is 750 Newton meter, this is 500, this is 250. If you will be taking section at 1, there is 0 torque. Section at 2, torque will be 250. Section at 3, torque will be 750. And there was the maximum shear stress in the length PQ. So the maximum shear stress in the length PQ will be, you know, that 500 plus 250 is the 750. So when you will be solving this, you will be getting this answer. So I feel as per the option, some error is there. Either the answer should not be in MPa. Okay, it should be in some other units. Fine. So A would be the answer for that. Okay, what is the second thing? Rotation of the free end. You know that the rotation of the free end will be nothing but theta of 1 plus theta of 2 plus theta of 3. You know that when we are going for this, this is T1, L1, G1, J1 plus T2, L2, G2, J2 plus T3, L3, G3, J3. If you will talk like that, you know that G and J are constant. So you can take G, J outside and it is T1, L1, T2, L2, T3, L3. If you will see that, so you can see for the first torque is 0. At free end, there is no torque. So T1 is 0. If you see length is 500 and 5000 mm. Okay. So you just need to put the values and get the answer. So try to solve it. Try to solve it, guys. Otherwise, I will be doing calculations with you. Okay, there is a mistake. This is 500 mm. That's what I was checking. It is 500 mm. So T1, L1, T2, L2 you need to do. Okay, this is 500 mm, 500 mm. That's what I was checking because I was having doubt how it can be 5000. So this is a misprint. So try to solve it, guys. We want the theta at free end. Theta at the free end. ओके कैलकुलेशन गलती कर दी क्या हमने पिछले वाले में? पहले ये बताइए इसका क्या आ रहा है? ओके सृष्टि, पहले ये बताइए इसका क्या आ रहा है? इट इज 80 GPa. सो आई विल राइट 80 इंटू 10 टू द पावर 3. और जब हम J की बात करेंगे तो पाई बाय 32, डायमीटर इज 50 टू द पावर 4. ओके, और यहां पर आपको पता है T1 0 हो चुका है. T2 कितना है? T2 इज 250 इंटू 0.5. अगर आप मीटर में लेंगे तो, mm में लेंगे तो 500, फिर प्लस 500 इंटू 500. अब ये याद रहे आपको कि इसकी यूनिट न्यूटन मीटर है और ये mm में है, तो उसके हिसाब से आप कन्वर्जन भी करेंगे. सोल्व दिस. Srishti, are you saying for the previous question C? First solve this, then we will once again check the calculation. I was also thinking the answer is coming around C. Okay, but you all said A, that's why I thought maybe my calculations are wrong. Okay, so tell me the answer. Tell me the answer for this. Here, you need to find out the angle of twist. Okay, Devashish is saying 1.22. Let me check. Are you getting C for this? Yes, Papa Ka Ghoda, you also tell. Srishti, you also tell. Tell me, everybody. So you would be having the theta at free end. The final calculation. When you are writing 18 to 10 power 3, it becomes MPa into pi by 32, 50 ki power 4. It is in mm. So you can see, we can put it all in mm. 250 into 500 plus 500 into 500. You can multiply with 10 to the power 3 to convert everything in mm. Yes. So everybody is getting 1.22 degrees. बोलो यार, सृष्टि आपका भी यही आ रहा है क्या? हाँ ना, कुछ तो बोलो. Fine, Devashish. So are we getting 1.22 degree for this? And what about this? This you are getting this or this? 0.58 आ रहा है. करिए कैलकुलेशन करिए. The answer for this is going to be 0.584. B is correct. कुछ गलती कर रहे हैं जो लोग C बता रहे हैं. Answer is 0.584 degree because I have already calculated before the session. It will be coming out to be 0.584 degree. Okay, so you are making some mistake. Papa Ka Ghoda and Devashish. Answer will be 0.584 degree. Okay, that is what I want to say कि इस तरह की calculation mistakes avoid करनी है इस तरह के questions में. Is it clear? Very good, aspirant. Shall we move on to the next question? 0.584 degree will be the right answer for this. Aspirant, this is for XC. This is for XC. Okay. So guys, I would like to tell you on 15th of October, you can appear for the scholarship test to get the scholarship up to 90%. And guys, there is a workshop on 18th of October at 7:30 p.m. which I will be taking on Know the Right Time to Start for GATE 25. If any of your junior is going to prepare for 2025 GATE, please inform him to join this free workshop. You can register from the link given. So guys, this is the next question from my side, after which Abhinav sir will be joining. So what is the answer for this question? A hollow circular shaft of inside diameter 10 mm, outside 20 mm is subjected to a pure symmetric bending moment of 200 Newton meter. The magnitude of bending stress at a point in the plane of loading, which is at a distance of 5 mm from the neutral axis. I feel everybody know bending stress formula is M into Y upon INA. if you want to find out at any fiber. Definitely aspirant, I will be taking that. I will be taking that, even that is already planned in the next week. So this is 200 Newton meter. Y is 5 mm divided by INA. INA is going to be pi by 64. D naught 4 by DI 4. It is 20 ka 4 minus 10 ka 4. Solve this and get the bending stress value. Papa ka ghoda, Devashish, try to give answer correctly this time, yaar. Last time you have made some mistake. Tell me. Tell me. Tell me, tell me. Yes, aspirant, Srishti, Devashish, Papa ka ghoda. Are we getting 135.8? 135.8. Devashish, once again some calculation mistake. This is the bending moment. This is the distance, pi by 64, 20 ka 4 minus 10 ka 4. Because the cross section is circular, na? So about the neutral axis, this is inside diameter, this is outside diameter. So you know INA is pi by 64. D naught 4 minus DI 4. Yes, पापा का घोड़ा. बताइए भाई, फिर अगले क्वेश्चंस पे आए हम. इतना समय तो नहीं लगना चाहिए कैलकुलेशंस में. So subscribe the channel, guys, if you have not done yet, because every day we are coming up for the session for BEL, for GATE, for engineering services, for PSUs. Okay. So the answer will be C for this, 135.8 MPa. So now Abhinav sir will be joining for the other questions. And then once again, I will come back for some of the questions from Mohrs circle side and all. Okay. Because we have seen already calculative questions. Now we will see some conceptual also when I will be coming again after Abhinav sir.
Sir.
जी sir.
Hello. बताइए sir.
Okay sir.
Okay. So guys, अच्छा 12th हो गया ना? 12th is done, I guess, है ना?
12th हो गया sir. 12th हो गया.
Okay, let us go with 13th. In 13th question, guys, there is a circular step bar. Step bar means different diameter and they are in series. Rigid support A and C के बीच में वो fixed है. Torque of 680 Newton meter is applied at the junction. Okay, the diameter of portion AB is twice that the diameter of BC. The reactions at A and C. So guys, I have done all this homework, okay, so that time can be saved. Let the reactions be here. Now, if here the diameter is D, then as per question, here the diameter is 2D. Now, what is the twist? Of course, this 680 is pushing it that side and the reactions will be here. So, TA plus TC is equal to 680. Okay. Now guys, phi AC will be equal to 0 because A is fixed, C is fixed. A is fixed, also C is fixed. So phi AC will be 0, yes or no? Okay, A and C both are fixed. So phi AC will be 0 and phi AC will be equal to phi AB plus phi BC is equal to 0. Phi is equal to TL by GIP. Cut a section here, see from right or left, your choice. Okay, so let us see from left. Curl the fingers, it is pointing inside, so it is plus. My sign convention might be, your sign convention is different. So TA into length L upon GIP. IP will be, guys, pi by 32 into D ki power 4. So pi by 32 into 2D ki power 4 plus phi BC. For phi BC, cut a section here, see from left or right. Let us see from left. Okay, so TA, if I curl it, it is inside, so positive. Curl the right hand like this, going outside is minus. Any sign convention you take here. If this is plus, that will be minus. Okay, so TA minus 680 into L upon GIP, that is pi by 32 into D ki power 4 is equal to 0. Now from here, guys, L cancel, G cancel, pi cancel, 32 cancel, D4 cancel, L cancel, G cancel, pi cancel, 32 cancel, D ki power 4 is cancelled. So TA by 16 will be coming na, 2D whole to the power 4. TA by 16, मेरा photo आ रहा है भाई, plus TA minus 680 is equal to 0. So from here, 17 TA by 16 is equal to 680 and TA is equal to 6 in 17. So 17 4 is 68, 40, 6 480. 480 is coming, guys. 17 to the 30, 40, 40, 16 to the 32, 64, 640. So if this is TA 640, so that will be 40. So option number A. Have you got it? Have it got it, guys? Everyone, please give me yes or no. Please give me yes or no. Okay. Great. Everyone got it? Excellent. Now 14th. Here also I have done the homework, so the time can be wasted. There is a thin wall cylinder with open ends is subjected to uniform internal pressure P alone. The wall thickness is T, internal radius is R, and the Young's modulus is E. The increase in radius of the cylinder due to the internal pressure. Okay. What is the increase in radius of the cylinder due to internal pressure? Now, this is the cylinder. And let me draw a cross section here, XX. Then after cutting the section XX, it will be looking like this. It will be looking like this. Okay. Yes or no? As it is open ends, so increase in length will be 0. As it is open ends, so here it is open. So here there will be no stress in longitudinal direction. Okay. Usually what happens if you take a small element here? If I take a small element here, okay, then the pressure will be P, and that P will be causing sigma H, and here it will be causing sigma L. In this case, as it is open, so sigma L will be 0. Sigma L will be 0. Yes or no? Everyone. So sigma H is equal to PD by 2T by equating the force in y direction. Sigma H into T. It is acting here, na? In all these, it is acting sigma H. Sigma H into T into L and sigma H into T into L. So total is sigma H into 2T into L. And downward force is P into D into L. This diameter into L, projected area. So from here, sigma H is equal to PD by 2T. In terms of R, if it is PR by T, it is PR by T. The increase in radius of the cylinder. Now, here sigma L will be equal to 0. Because in longitudinal direction, there is nothing. So, my friends, everyone, what is epsilon H? Considering P will be very small because it is thin cylinder, na? So T is very less. So as compared, T is very less than D. Okay, this ratio of d by t is 15, 20, 25, 100 times. So sigma h is very more than p. So sigma h is very more than p. So I'm neglecting p. So epsilon h is sigma h by e. Other terms are 0 because sigma ln this is 0. So epsilon h is sigma h by e. So pr by te, and this is delta d by d. So what they're asking, the increase in radius. Okay, so delta d will be, or it can be delta r by r also, delta r by r. So it is pr square by te, pr square by te. That is option number C. Give me yes or no. All of you, everybody, guys. You see what is the difference in XZ? That here they have opened it, open end is subjected. Okay, so due to that open ends, the sigma L will become 0. So therefore you have to modify the formula. If you have written, remember the formula of hoop strain, you cannot apply, because that in that hoop strain formula that you studied, that is sigma h by e minus mu sigma L by e, but that is 0 here. That is 0 here. Give me yes or no. Give me yes or no. Are you getting the same answer or not? Are you getting the same answer or not? जल्दी से बता दो, जल्दी से बता दो. Getting same? Okay, now 15th question. Guys, a cylindrical steel bar of uniform cross section is subjected to, there might be fixed condition or whatever condition, is subjected to axial force P and a torque T. Okay, so linear elastic, everything is there, so that strain energy formula can be applied. It is only applied when support is not sinking, thermal temperature change is 0, and material is homogeneous and linear elastic. So strain energy we can apply. So strain energy is 20p square plus 8t square into 10 की power minus 6. Now axial extension of the bar is only due to P, not due to T. Okay, so del U by del P is equal to deflection. So this will be 40p. Okay, 40p. Differentiating this with P will be 0. Okay, so 40p and P value is given kahan gaya? 10 Newton. So that will be deflection. Del U by what is asked? What is the value is 40 into this. The axial extension of the bar for P, 40, the 10 की power minus 6 is also there, na? So 40 into 400 into 10 की power minus 6, and 10 की power minus 6 is micrometer only. 10 की power minus 6 is micrometer only. Have you understood? Have you understood, everyone? Okay. So guys, thank you. Now Dheeraj sir will be taking the other questions. Okay, and Dheeraj sir is having a workshop on 18th of October. So 18th of October is Wednesday. 18th of October, Wednesday. So Wednesday, that means Dheeraj sir is coming to Noida from Hisar. And if he's coming Noida, that means we'll be having a cricket match that day. Okay. So know the right time to prepare for GATE 2025. This is at 7:30 p.m. So from 9 p.m. we will be having a match. Okay. And the scholarship test is on 15th of October. You can attempt this test and get the discounts on our courses. Thank you. So now the relay race ka last one lap Dheeraj sir ke liye, Usain Bolt.
Fine, guys. So guys, first of all, this question, as we were having a problem with the calculation, so I have rechecked it. The answer is C only, 30.56, which I was saying. Okay, so I feel Papa Ka Ghoda have done some calculation mistake. So 30.56 is correct. Okay, so it will be, the answer is 30.56 MPa, because when you will calculate what was the things we were doing mistake, you were not dividing by pi. Okay, because it is pi d cube by 16 now. So without pi you were getting answer A. So that was the mistake in calculations you were getting. So answer will be C for this. Okay, so guys, let us move to the next question. Like sir have solved up to 15, this is the 16th question. Now we are having 5 more questions left, out of which 2 are homework for you. Okay. So a cantilever beam of length 3L is subjected to 2 forces, each of magnitude P as shown in the figure. The flexural rigidity of the beam is EI. Assume linear elastic material and small deflections. So my dear, this is load P, this is load P. And they are asking you which of the following statement is true. The magnitude of bending moment in AB portion is 0. The magnitude of bending moment in AB portion is PL. The magnitude of bending moment in AB is 2PL. The magnitude of bending moment in portion AB varies linearly from 0 to PL. So this is the beam given, and this is, they have said this is A, B, C, and D. We are having 1P upward, 1P downward. And now I feel you can solve what would be the right answer. Yes, aspirant, but that will not be on the YouTube. Okay, that will be on the ground. So what would be the answer for this? This is question number 16, guys. Out of 5 questions, 2 are homework, 3 we will be doing. Tell me, guys. Everybody. Aspirant, Devashish. I feel if you can see, they are asking majorly for which portion? AB portion. So this is the AB portion. Na? So you can take a section here if you want. So you can write the bending moment at section XX. This is, let us say, X. So this is creating sagging plus P into X minus P into X minus L. Okay. Is it clear? So I feel from that you can say the bending moment is PL. What would be the answer? B is the answer. So can we say the magnitude of bending moment in the portion AB is PL? So if you want, I am going to make the BMD for this. Okay. So if you will see the BMD, it would be coming like this. Initially, it will be increasing from 0 to PL, then it will remain constant. So my dear, this is B. Okay. Sorry, this is C. This is B. This is D. This is A. They are asking you the deflection due to bending at point B. So you need to find out the deflection at B. This is your homework question. I have already shown you the BMD. This is PL. Okay. This is 0. So you can use the moment area method and find out the deflection for this case. Okay. So I expect you will be giving the right answer. So you can answer in the comment section of this question so that I get to know who are taking this session serious. Then I will be telling you there that answer is correct or not. If you will give wrong answer, I will share the solution on my Telegram. Next question is question number 18. This is a steel bar of rectangular cross section is heated uniformly and the rise of temperature is delta T. The Young's modulus is E. The Poisson ratio is mu. The coefficient of thermal expansion is A. The bar is completely restricted in axial direction and lateral direction. Okay, before we go to the question, on 14th of October to 20th October, you can appear for the first Mega Mock Challenge. We are going to have this schedule total 1, 2, 3, 4, 5, 6, 7, 8. 8 tests you will be getting for free. Okay, before gate. And for this first test, the syllabus is aptitude, mathematics, thermodynamics, and heat transfer. For that, you can appear 65 question, 100 marks, 180 minutes. So you can download the app. Link is there in the description of this session. Okay. So this is the question. I am showing it. This is sigma, sigma, sigma. Why this stress will come? Because temperature increased by delta T. And they have said E is the Young's modulus, alpha is the coefficient of thermal expansion, mu is the Poisson ratio. You need to find out the value of sigma if the strain in all the directions they have said it as it is restrained in axial direction, completely restrained in axial direction and lateral direction. So strain is 0 in XX, YY and ZZ. So they have mentioned strain is 0 in XX, YY and ZZ. So tell me guys, strain is 0 in XX, YY and ZZ, completely restricted. So you need to find the value of sigma. Yes, if you have seen this question, this is the PYQ of XC. Every teacher generally do this question in the thermal stress. This is a PYQ of XC. Okay. So it have not yet appeared in gate mechanical or civil. So there are fair chances that it will come soon. Try to solve this question. After that, we have 3 more questions, out of which 2 I will be doing, 1 will be homework. Tell me. Yes, if you want the hint, you can see that when we are talking about the volumetric strain, because of thermal, you know that it can be 3 alpha delta T. And because of loading, it will be compressive, which is 1 minus 2 mu upon E into sigma XX plus YY plus ZZ. Okay, you can write it like this. But you know, sigma XX, sigma YY, sigma ZZ all are negative. So 3 alpha delta T will be 1 minus 2 mu upon E into 3 sigma. Why? Because in reality, this total is 0. From here, you will be getting the value for sigma. It is a very good question. Tell me the answer, aspirant. Srishti. Tell me the answer, aspirant. From here, you will be getting the value of sigma as minus. You can ignore because minus indicate it is compressive. Okay, so you need not to worry about minus sign. So you know it will be E alpha delta T divided by 1 minus 2 mu. Why? Because 3 and 3 will get cancelled out. So E alpha delta T 1 minus 2 mu, C is the right answer. So Srishti, I feel I have told you the answer you were saying for torsion question was correct. Okay, have you noticed I told that? I am once again showing you that. That calculation you have done it correctly. The answer is 30.56 ampere. Okay. But here the answer is E alpha delta T by 1 minus 2 mu. Here answer will be C. It is not 1 plus 2 mu, no? It is 1 minus 2 mu. Got it? Okay, then this is your homework. So one part I have done, second part is homework. He is saying assume that the bar is allowed to deform freely in the lateral direction. So in the lateral direction, they have set the stress to be 0. While keeping the axial direction restrained, sigma XX is non-zero. So you can say that epsilon XX is still 0. And they are asking the percentage change in the magnitude of axial thermal stress. So previously, the sigma value came E alpha delta T upon 1 minus 2 mu. Now you will be finding the new value of sigma by these conditions. And then you will say sigma new minus sigma previous by sigma previous into 100. And you will get the answer. So you need to give the answer to this question as well in the comment section. So 2 questions I have given you homework. This is your homework number 1. This is your homework number 2. Okay, last 2 questions now we will be solving. Question number 20th in front of you. Question number 20th in front of you. This question says the stress induced in an unconstrained rod that is heated uniformly depends on. only on the coefficient of expansion, only on the temperature change, neither on the coefficient of expansion on temperature change, both on the coefficient of exchange and temperature change. What would be the answer for this one? Second last question for today. Tell me, guys, tell me. I will be taking the next session on the other parts of solid mechanics, that is engineering mechanics and vibrations. So the answer for this will be C, because they have said the unconstrained rod. Unconstrained rod means free expansion. For free expansion, stress is zero, irrespective of anything. So the answer is C. This is a 1 mark question from XC, can repeat in mechanical and civil. Last question from Mohrs circle. For a biaxial state of stress, sigma xx 40, sigma yy minus 20, tau xy 30, what will be the center of Mohrs circle? This time I won't answer from all of you correctly. Last question for this particular session. Last question for this particular session. Last question for this particular session. Tell me, guys. I feel all of you are aware that the coordinate of Mohrs circle are sigma star comma 0, as center lies on x-axis. So these two options are automatically wrong. So then you know sigma star coordinates are sigma xx plus sigma yy by 2. So the answer is 40. C is the right answer. So guys, this was the session. Now we will be meeting again tomorrow 10 p.m. in the night for mathematics session, where I will be teaching you matrix algebra, and that will be a revision kind of session where we will see concept fastly with the questions. Okay, means it will not be CTQ, it will be concept plus question, like we have done for the probability. So goodbye for this particular session, guys.